Hello everyone, my name is Vaishnavi Kamble and I am pursuing my civil engineer degree from MIT OE and I am here to present my topic which is classification and types of bridges. In this presentation, we explore the classification and types of bridges, their essential components and important concepts like economical span, afflux, HFL and scour depth. We will also examine the loads that bridges must withstand, IRC load specifications, and analyze bridge failures in India. So basically, types of bridges are classified on the basis of material, structural system, and function. Based on material systems are timber bridges, masonry bridges, steel bridges, reinforced concrete bridges, and composite bridges. Based on structural system, they are divided into a beam bridges, arc bridges, suspension bridges, cable stayed bridges, and truss bridges. Based on function, highway bridges, railway bridges, pedestrian bridges, advocate bridges, and combined bridges. Basically, bridges can be classified based on several factors including beam bridges, arc bridges, truss bridges, and cantilever bridges. These are the basic classifications. I'm explain about the beam bridges. These are the simplest type of consisting horizontal beams supported by piers or abutments. They are economical for short to medium spans up to around 60 meter. Ginder bridges using steel or concrete ginder for reinforcement are the common type of beam bridges. Arc bridges, these bridges used to curved arc to transfer the load the abutments. They are strong in compression and can be made of stone, concrete or steel. Arc bridges are suitable for medium to long spans. Now I am going to explain about the truss bridges. These bridges are composed of interconnected triangular units forming a rigid framework. Truss bridges can carry heavy loads over long spans and can be made of wood, iron, or steel. Common trusses design include Pratt, Howe, and Warren trusses. Now I'm explain about the cantilever bridges. These bridges are built using cantilever structures that project horizontally. Structures that project horizontally into space, supported on only one end. Cantilever bridges often have three spans, with the outer spans anchored and the central span resting on the cantilevered arms. They are suitable for medium to long spans, especially where temporary supports are difficult to build. Now I am going to explain about the suspension bridges. These bridges have decks suspended from massive cables that runs between tall towers and anchored at the ends. Suspension bridges are ideal for very long spans over 500 meters as the cables are strong in tension also. Now cable stayed bridges. Similar to suspension bridges, cable-stayed bridges also use towers and cables, but the cables are directly attached to the deck, running at an angle to the lowers at the towers. They are suitable for medium to long spans and are often aesthetically pleasing. And now, tied arc bridges. These bridges are also known as the bowstring bridges. These combine feature of a arc and suspension bridges. The arc rises above the deck and the vertical ties connected to arc to the deck, supporting it. The horizontal thrust of the arc is combined by a tension member running along the deck. Now these are the components of the bridges. Now I'm talking about the components. First one, so first of all, we are talk about the superstructure. The part of the bridge are that directly supports the traffic load. It includes deck, the surface on which vehicles or pedestrian travel. It can be made of concrete, steel, or timber, or composite material. It is called as deck. And ginders or beams, horizontal structure members that support the deck and transfer the load to the substructure. They can be made of steel, reinforced concrete, or pre-stressed concrete. And the third member is trusses. In truss bridges, the deck is supported by a truss system. Fourth one is arcs. In arc bridge, the arc structure supports the deck. And the fifth one is bearings. Devices placed between the superstructure and the substructure to transmit load and allow movement due to temperature changes, creep, and other factors. Now we are talking about the substructure. First of all, piers. Intermediate supports for multi-span bridges. They are typically vertical columns or walls made up of concrete, steel, or masonry. Abutments. Abutments and support of the bridge that also retain the soil of the approach. Embankments. Pier caps, horizontal members on the top piers that provide a seating area of the ginders or other superstructure elements and distribute the load. Wing walls, walls extending from the abutments to retain the soil of approach. Embankments. Foundation, the part of the bridges that transferred the loads from substructure to the underlying soil or rock. And these are the common types of foundations, which is shallow foundation, deep foundation, pile gaps. Then we are talking about the concept of economical span. Economical span definition is of the bridge is the span length for which the total cost of the bridge, including both the superstructure and the substructure, is minimum. Determining the economical span involves considering the cost of deck, supporting structures, gender trusses, etc., piers, abutments, and foundation. As the span length increases, the cost of the superstructure generally increases, while the number of piers required for a given total length decreases, potentially reducing the substructure cost. The economical span is found by the balancing these costs. There isn't fixed economical span for all bridges, as it is depends on various factors such as the type of bridge, material used, site condition, and the cost of the labor and materials. However, general economical span range are often associated with different bridges types. Example, slab bridges up to 9 meter and the ginder bridges which is 10 to 60 meters. Now we talk about afflux, HFL and scour depth. Afflux refers to the rise in the water level upstream of the bridge due to obstructions caused by the bridge structure in a waterway. It is critical parameter in a bridge design. Excessive afflux can lead to flooding upstreams and increased soar around bridge foundation. Factors which are affecting the afflux, which is bridge opening size, pier shape and alignment, flow velocity. Now we are talk about the HFL. The full form of HFL, which is high flood level. HFL is the highest level that waters has reached during floods at the specific location. Designs must consider HFL to ensure adequate freeboard means clearance between the highest water level and the bridge's superstructure. HFL, high flow level determination methods. First one is historical flood records, hydrological studies, and statistical analysis. Now we are talking about the scour depth. Scour depth is a depth of erosion that occurs around bridges foundation due to flowing water. It is one of the primary causes of bridge failure in worldwide. Types of scour are general scour, local scour, and contraction scour. So basically afflux is the rise in water level on upstream side of the bridges or other hydraulic structure compared to the water level that would have occurred if obstruction wasn't present for the same discharge. Essentially, bridge constricts the flow, causing the water to the backup. Now, these are the loads acting on the bridges. First of all, we talk about the dead loads. Bridges are designed to withstand various types of loads to ensure safety and stability. According to Indian Road Congress (IRC) standards, the primary loads considered in a bridge design are: first of all, dead load, the permanent load due to self-weight of the bridge structure like deck, ginders, piers, etc., bearing surface, railings, and other fixed elements. It is a static load that is always present. Second, live load. The live load is basically transient load caused by moving vehicles, pedestrians, and other temporary loads that the bridge may be subjected to during its service life. The IRC specifies standard live load classes to be considered in design, including IRC AA loading, IRC class for 770R loading, and IRC class A loading. Impact load or impact allowance accounts for the dynamic effects of moving vehicles such as vibrations and sudden application of loads. It is expressed as fraction or percentage of the live load and depends on span length and the type of vehicle. And the special loads means special load includes the longitudinal forces, centrifugal forces, and thermal forces. IRC load specification. These are the specifications of IRC. First one is standard specification and code for practice of road bridges. The primary code that governs the design loads for highway bridges in India, specifying various load combination and factor of safety. Standard design vehicles. IRC specifies standard design vehicles like IRC class A, as I told you, and 70R tracked vehicle, 70R wheeled vehicle, IRC class A. So thank you.